All right, let's take a look at section 9.8. And when we look at section 9.8, factoring by grouping, this phrase, factoring by grouping, kind of gives you a hint as to the fact that you have to do these problems just a little bit different. So when we look at this, let's start with some common examples, things that we're familiar with. The first thing is if we look at 6x minus 6y, remember our first step whenever the directions say factor is always, can we pull something out or can we undistribute something? And in 6x minus 6y, we have a 6 in common. And when we undistribute that, we were left with x minus y. Or we pulled out, we divided by 6. The same thing can be said here in number 2, that if we have a diamond times x minus a diamond times y, right, it's just ugly, but it's still an undistribute problem. We would end up with a diamond, because that's what they have in common. We could divide them both by diamond. And if we did that, we would be left with x minus y. So then we just take it one step further. So we pulled out a monomial of 6. We pulled out this ugly looking thing of diamond. And now when we get to number 3, we're going to say that they have in common this quantity, a plus b and a plus b. So the common, or the ugly variable, what they're both divisible by, is a plus b. And what we're left with is x minus y, because we would distribute a plus b times x minus a plus b times y. So the biggest question is, when are we going to use this step? And the first is that there are 4 terms. So if you have a polynomial that has 4 terms, then chances are you're going to use factor by grouping. That's kind of the biggest red flag, is that we have 4 terms. The steps for factoring by grouping is to use parentheses to make 2 groups. Each group should share common factors. I think next to this, I would also put descending powers of x, or variables in order. And when I say variables in order, I'm talking about having, like in number 4 here, sorry, that we have ax plus bx. Then we have ay plus by. There's kind of a pattern there. So when that happens, the first thing you're going to do is just simply make 2 groups. So use your parentheses. So let's group the first 2 together, and we're going to group the second 2 together. When we do that group, we have to be careful about what we leave in the middle. If we leave a subtraction in the middle, then we need to change the next sign, because technically we've already undistributed a negative. So when we get to 1, I'll show you again. So I made my 2 groups, and now I'm going to look at each group and see what they have in common. So ax plus bx, oh, they have an x in common, and I undistribute it. So I'm left with a plus b. Plus, now we look at our second group, and they have a y in common. So we'll factor out or GCF out a y, and we end up with a plus b. And now, because I have this weird looking stuff, I want to check that I have a common factor. So again, x times a plus b, it's a diamond, plus y times a plus b. Oh yeah, those 2 quantities match. So we can write that matching quantity first. And then we start our next quantity, and we put in whatever we factored out first, plus or minus whatever we factored out second. And now we have a product. You try number 5, then come back and check your work. So hopefully problem number 5 was nice and easy for you. Now let's work through problem number 6 together. In problem number 6, the first thing we check for is it in descending powers of x, or are my variables in order? Because sometimes we might have to reorganize a problem in order to do it. But in this case, it is organized. So we'll go ahead and we'll regroup the first 2 grouped with The second two, we're checking that we left an addition in the middle, because if it were subtraction, we'd change that sign because we technically undistributed a negative. And now we do GCF. X to the third plus 3x squared. Well, they have x squared in common, times x plus 3 plus 2x and 6. They have a 2 in common. That leaves it with x plus 3. We're checking for duplicate, or that diamond, that weird shape or shared ugliness, and we have it. They're both x plus 3. So we keep that, and we start our parentheses, do leftovers plus leftovers. And that's where we finish. Would you please go ahead and give problem 10 a try? Number 10 is the one I'd like you to try. Oops, actually I forgot. Number 10 is the one I'd like to do with you. Because number 10, when we go to group it, the first thing you'll notice is that we left a subtraction sign in the middle. And when we leave a subtraction sign in the middle, we have to just simply take this next sign and change it. So since it was subtraction, it became addition. If it was addition, it would become subtraction. And we go through the exact same process. B to the third and 8b squared have a b squared in common. That would leave us with b plus 8 minus 3b and 24. They have a 3 in common. That would leave us with b plus 8. And if you're doing a factor by grouping problem and you notice that your two quantities aren't quite the same, then go back and see if that's your mistake, is that you left that negative in the middle and didn't change your sign. So if these don't end up exactly the same, then you should switch them and adjust them. So we go from here, we have our duplicate quantity, we can write our answer. B plus 8 times b squared minus 3. All right, give number 12 a try, for real this time. This time you really do it on your own. Number 12. How did you do? Again, it was a subtraction problem, and we had to change that subtraction to addition. There's one other type of problem that I want to make sure we address, and it's right here. When we see that these two quantities are almost alike, what can we do to make them be exactly alike? And the easiest way to tell you this is that if this happens, look at it, y minus 1, and this one is 1 minus y. The easiest way to tell you to fix that is to undistribute a negative and reorganize your addition. So that, I'm going to work it off to the side here. 1 minus y is equal to negative 1 times negative 1 plus y. I undistributed a negative. So I pulled out a negative, but I still wanted to have the same value. So double check that when I distribute, does it get back to 1 minus y? And hopefully you see that it does. So that once I have this negative 1 plus y, with an addition, I can reorganize my order. So that negative 1 times y minus 1. I'm okay with you just memorizing that 1 minus y is equal to negative 1 times y minus 1. I'm okay if you memorize that, but I wanted you to know why it works. So in the case of this problem, what we can actually look at on our second line is the fact that 2y squared times y minus 1 minus 7, right? I undistributed that negative, times y minus 1. Now I have duplicate quantities, and I can finish factor by grouping. Now the second piece of section 9.8 is about factoring polynomials completely. I'm going to put up a separate video for that one, so go ahead and tune back.